Hi, pre-algebra students. So today we're going to complete notes for section 1.3 on solving equations with variables on both sides. So far we've solved one-step, two-step, and multi-step equations. Today we're going to look at equations with variables on both sides, which means we're adding this extra step of collecting the variables. So if you notice in our first equation, we have a variable term on the left and a variable term on the right. Normally we would combine like terms, but because these two terms are on opposite sides of the equal sign, in order to collect them, we have to use an inverse operation. So since my constant is already on the left, my goal is going to be to get the 2x on the right-hand side so I can collect 7x. So I need to use an inverse operation in order to do that. So using 2x both sides. Over here, this is my 0 pair, and I have 15 left over. Using my integer rule, negative 7x plus 2x is negative 5x. If I then divide both sides by 5, because I'm now at a simple one-step equation, using my integer rule, 15 divided by negative 5 is negative 3. And over here, my 5's cancel. So that's my solution. So it does ask me to check my solution. So remember, you're going to take the value of your variable, plug it in place of x, every place you see it in the equation. So my check is going to say 15 minus 2x. Sorry, just said plug it in. Let's try that again. So minus 2 times negative 3 in place of x equals negative 7 times negative 3. I'm going to evaluate using order of operations. So here a negative times a negative is a positive. So it's 15 plus 6. And negative 7 times negative 3 is positive 21. If I finish this left-hand side, you can see that both sides are equal to 21. Therefore, it checks. Okay, this time would be a good idea to stop if you need time to finish copying. Otherwise, I'm going to go ahead and move on to example 2. And in this one, notice we're just adding distributive properties. We have to simplify before we solve by distributing, and I've got that on both sides. So I'm going to start by distributing negative 2 on the left, negative 2 times x, negative 2x. And then remember, because there's a subtraction sign in front of the 5, it makes that 5 negative. So it's negative 2 times negative 5, which is positive 10. And then over here, we're going to distribute the 6, both terms. 6 times 2 is 12. And then a positive times a negative is a negative. Half of 6 is 3, so that's 3x. And now we're down to that equation with variables on both sides. So notice I have a variable term on the left and on the right. So the goal is to collect those on one side using an inverse operation. I'm going to choose to add 3x to both sides. There's a little bit of strategy involved there. I noticed that 3 is bigger than 2, and I just want this to come out to be a positive. So that was part of my decision. And I'm now down to a simple one-step equation. So I subtract 10 from both sides. So x is equal to positive 2. It does not ask us to check here, so I'm going to go ahead and move on, but I will remind you it's always a really good idea to at least do a mental check and plug it in and make sure your answer makes sense. The on your owns are up next. Please follow your teacher's directions in terms of solving the on your own problems. I'm going to go ahead and keep moving. So in the second half of our lesson today, we're going to talk about equations that don't have one solution. So these are called our no solution or infinitely many solutions. So let's talk about both of those. When an equation has no solution, what's going to happen is that it will form a statement that is not true for any value of the variable. So for example, the bottom will say 0 equals 2, which is, of course, not true. Okay, or you can say false. I like to write that as 0 does not equal 2 because it is a false statement. So saying 0 equals true is false. Okay. Next, we're going to talk about infinitely many solutions, and that's what you obtain when an equation is true. We need to fix this vocabulary a little bit. We're going to clean it up. So we need to get rid of the word not, because an infinitely many solution, the equation is true for all values of the variable, and change this to say 2 equals 2, because when it's infinitely many, it would be the same on both sides. Let's look at an example of each of those. In the first equation, notice, first of all, you can't do any simplifying. There's no distributive property or combining like terms. So I'm going to start by collecting the variable on one side. So using an inverse operation, I add 4x to both sides. And notice here, the variable term actually cancels out on the left and the right because there are 0 pairs on both sides, leaving us with 3 equals -7, which, like I said earlier, is not a true statement. That is false, which means this equation is a no solution. You can abbreviate that as NS. In example 4, please note that first we need to simplify this one by distributing the 4 on the right. I know multiplying by fractions is sometimes hard, so what I typically do is a little scratch work out here in the margin. So notice here I can cross cancel. 2 goes into 4 twice, and then multiplying straight across, 2 times 3 is 6. So that means when I multiply 4 times 3 halves x, I get 6x, and then 4 times 1 is 4. I still have my 6x plus 4 on the right, or on the left, sorry. So combining my, collecting my variables on one side, I'm going to subtract 6x from both sides, and that leaves me with 4 equals 4, which is a true statement. Therefore, this one is an infinitely many solutions. Okay, and up here you might have already noticed at this point that both sides of the equation were exactly the same. That is called an identity, when both sides are exactly the same. So as soon as you get to that point where you can see the two sides are the same, then you know it's an infinitely many solutions. All right, so at this point you have some more on your own to either try or finish up in class tomorrow, depending upon your teacher's directions. So I'm going to let you try it out, and we'll see you in class tomorrow. Have a great night.